Everyone, welcome to this session. Hope everyone is doing well. Let's start this session from where we ended the last session, which was introducing IoT devices. Right. So we took in the last session we took an introduction to IoT devices. Right. The definition goes as the Internet of Things, or IoT, describes the network of physical objects or things that are embedded sensors, actuators, processing ability, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. So in this definition, we talked about these physical objects or things in Internet of Things, which are networked together and making embedded system or embedded devices. Right? We talked about cameras, temperature monitoring, light, motion sensors, contact sensors, plugs, smoke detectors, air filters, and control centers. And we also talked about complex embedded devices, which are part of IoT, as robot arms, smart fridges, Roomba vacuum cleaners, smart locks, smart hospital beds, virtual reality gaming, to health monitoring, driverless cars, to weather monitoring devices. So then today we are going to look at examples of IoT applications. So before looking into this, we will try to understand what are examples of IoT devices, what are the points that we are trying to look at in this network, and what are the examples of applying this. So let me paste here a small picture. So if you take this diagram of IoT devices, right, you can see that each IoT device is represented at end of each network node. So inside each IoT device, there could be another small network of sensors and other devices which are embedded together to make that particular IoT device, right? So in the last lesson, we were looking at these examples of these devices, these individual devices. Now today we are going to look at this whole picture, how each device is going to communicate with another device and send the data through the internet to any other devices which are looking for that particular set of data. So we are going to look at how Internet of Things is applied, how the networking happens. Now, as we have checked what are the devices, let's see how these devices connect to each other and make IoT, and how IoT helps humans to be more productive, to be more efficient, and to take help, how humans take help in automating things from IoT, right? So in examples of IoT application, we will be now looking at these devices which we talked about before, examples of these devices working together in conjunction through the internet or through a network, right, to make Internet of Things, to take in data and give a productive and efficient outcome. So So let's look at the first example. The first example we will take from weather monitoring devices, right? Last time we were talking how weather monitoring devices can be used individually inside farms, right? And for this example, we are going to look at application, not all the applications, but a single application, right? We are going to use a single application in this example of a IoT weather monitoring device and how that can be used to make a productive temperature control or control the air, the quality of the air for human habitation inside. It could be inside a room, it could be inside a home, an apartment, a large scale housing project, or a large scale office building, manufacturing plant, or it could be anything in between, right? So let's look at this example. So we have a weather monitoring device, right? Don't think, when coming into Internet of Things, it's not a single weather monitoring device that would give information. Let's take Sri Lanka for a moment, right? Think that these weather monitoring devices are fixed, one in Colombo, right? And going through, right, each 10 kilometers inland towards, let's say, towards Kandy, right, through Kalania, each device is fixed along the way, right? So what that means is this will collect data from a far away location towards Kandy. So a person in Kandy can actually know when clouds are coming in, when from Colombo side, right? Because it will there will be monitoring stations along the let's say Colombo Kandy road, right? This is just an example. So when clouds are coming from the western side, from the west side of the sea towards Colombo, then it goes towards the hill country, that can be monitored. The wind speed can be monitored, and then the estimation can be taken. How long will it take for those clouds to reach Kandy? Then these weather monitoring devices in Kandy can check the humidity and rest of the information, the temperature changes and humidity, to predict a time when rain is going to take place, right? This is a simple example of multiple weather monitoring devices working together to predict an outcome or to give sufficient data to make weather related predictions. Now think all these monitoring devices not in a straight line from Colombo to Kandy, but located all around Sri Lanka. Then we would have a real-time understanding of whether it's the temperature, humidity, wind speeds, or any other inside Sri Lanka. If you multiply that network into a larger network, bigger countries with bigger landmass like India, China, Australia can have a better understanding of vast amounts of land, how the weather actually works. and that data can be taken into a cloud, into cloud computing, and that data can be collected and make weather models to predict weather in the future. Right, not only live weather forecasting, but it could be used like monitoring the weather for 1, 2, 3 years. Then the next year, if the temperature is like this, if the humidity is like this, if the wind is like this, then we can expect an outcome, whether it's rain or not. Right, that is one of the ways. But here in this example, we are talking about specifically about temperature. So the weather monitoring device, or the IoT device, which is monitoring the weather and the temperature nearest to that particular location, can give data through the internet to the thermostat, which will be controlling the air conditioning or the heating of that house, of that residence, or of that building, or of that manufacturing plant where a lot of people are working. So that data collected from the weather monitoring device, which is closest to that particular location, can give out this data to the thermostat or the to the temperature controlling system, can help to maintain a temperature which is comfortable for humans who are living inside that particular room or environment. Let's take examples. In Sri Lanka, when it rains, we all know the temperature goes down. Right? So when the temperature goes down, if the AC stays at the same level, people will feel uncomfortable. It will be too cold. So adjustments have to be made. So rather than somebody dedicating time to check these things and taking time to fix it when the problem arrives, before the problem arrives, before it gets too cold, the thermostat can collect data from the environment, from the weather monitoring tool, and directly use that data to control the temperature of the AC. Same goes the other way around. When if it is too hot, the thermostat can increase the AC to colder levels to maintain the proper temperature inside the particular room or the building or any other location which temperature control is needed. Two things happens from this. Number one, it is comfortable for the human beings who are staying inside. It could be a hospital where there are thousands of patients. It could be a manufacturing plant where there are thousands of people are working. It will be comfortable to the human being. The other thing would be, there will be storage device. Also another example would be storage locations, right, would use that data to control their temperature, because there are some things that are needed to be stored at a particular temperature. When if it is too cold or when it is too hot, the product will get destroyed. So that is being also used. The other point is, this method will create energy savings, and it would be efficient to create energy savings. In a winter time or in a cold time when there's rain, nobody needs to use air conditioning a lot. So thus energy will be saved, and if it is a large company or even a house, there will be savings made in the electricity bill. So these points are also important. It's becoming productive and it's becoming efficient. It's going to be financially efficient, and if it's going to be physically comfortable for a human being to stay in an environment where where IoT devices are controlling the temperature. Similarly, another way is to the weather monitoring devices can monitor the atmosphere and check whether if there is too much particles which are harmful for human beings in the environment, which means pollution, smog is there or not. And that data also can be relayed to the through the internet to another IoT device, in this case a air purifier. So the air purifier can switch on and purify the particular air in that particular environment, right? That so a air purifier is something that consumes a bit of resources, including electricity, and there are filters inside and so on and so on. And switching on these filters when it is only needed is a very efficient method. And to have that efficiency and productivity, and to help humans have good breathing environment, this using the data which is collected by a IoT device outside the particular building where humans live, and through the internet relaying that information to the IoT device which is inside that building or room or house or manufacturing plant, is a good example of how IoT network works, right? This is a simple example of how one IoT device with sensors collects data, and through the internet and use of cloud computing in some instances to process that data, can send the needed data into other IoT devices to get a positive outcome. In this particular case, it's the AC, or it could be an air purifier. This particular example is solely concentrated on making a good atmosphere for a human being to live in, and to do that in a productive and efficient manner. So this is another before we talked about when talking about the device, we talked example about farming. This is a single example of how that collected devices in real time can be used to control the environment inside buildings where humans are living, right? Mostly in Sri Lanka, because again I will stress this out, if it is mostly inside Sri Lanka, the temperature factor affects less. But if you take countries with drastic temperature differences, if you take Middle Eastern countries, the temperature differences between night and day is a lot, maybe 20-25 degrees even. So in that particular scenario, it will be very helpful for people who are living inside a building or in a, let's say, in an office environment, when the temperature is maintained to a certain level, looking at the temperature outside the building. In a winter scenario, it's the same way around. The heaters, right, if it gets too hot inside the building, then it will be hard for a person to stay with that particular temperature. So it is needed to be maintained comparative to the temperature outside. If there's a harsh winter outside, having a heater put on low settings will not help the people inside the building. So that temperature should be maintained, the energy usage should be maintained also comparative to the temperatures outside. So if you take those scenarios, use of IoT is really important, and it's efficient energy wise, and helping giving people a good environment to either work or live, right? This is one of the applications of IoT. Let's go to another example. Let's look at a scenario where IoT is used not only for maybe a single thing, but where a couple of events are taking place at simultaneously, right? But rather than having human intervention, how quick response and efficient response can be taken by giving a IT solution or giving a IT application to it. So this is about a critical example. It's about a fire starting inside a residence, right? Inside an office building, a manufacturing plant, or something. For now, let's take an example of an office building, right? Large scale office buildings, let's say the World Trade Center, if we are going to give a IoT application, how would that for battling fires, right? For safety purposes. So how can we apply these IoT devices we looked at as examples above to help protect the building from fires? Let's look at that. First and foremost, fire regulation is there for large scale buildings, and this monitoring these fires or having smoke detectors for safety is a compulsory thing for large scale buildings going into the future. So we are actually looking at a very practical and commonly used example, and we are trying to see how IoT can help to stop that fire quickly and help the people needed. Okay, let's for example take the World Trade Center of Sri Lanka. It's a large building. A lot of people are working inside that building. A lot of officers are there in that building. So if we use a smart IoT, if we use a IoT smoke detecting device, right? These devices will be then connected to control panels, right? Here, of course, the control panels will not come as Siri or voice activated. It will more come as a screen or a laptop, right? This is just for examples, right? It would basically come as a panel or in the computer from the central control room, right? But for now, because just to show that this section would be the control system. So the smoke detectors will detect smoke in a particular flow in a particular area, right? And they will judge that this smoke and as well as the heat is equivalent to a fire starting. They will relay that information quickly to the central the controller or the processing unit. Then, as this is a IoT system, automated processes will take place, which means that even if there is no human monitoring or if there is human error, that can be avoided. So when a smoke detector detects smoke and knows that there's a fire, the first thing will happen is it will direct that data taken from the sensors into the control or the processing unit. That processing unit or the control unit will process that particular data, right? And first it will send that data to two places, one into the cloud or into the internet, and the other, it will activate the fire suppression system inside the building, right? Particularly because this is an IoT system, this can be made just so that the fire suppression system in that particular location, that particular flow gets activated first, rather than activating the whole building fire suppression system and drenching all the equipment, computers, and documentation and everything with water and destroying them. If it is a small fire located in a single flow or a single area of a flow, the IoT systems can collect the data to find where the location is from the smoke detectors and activate the fire suppression system at that particular location only first, to see if the fire can be stopped. While the fire suppression system comes into play, the smoke detection systems or the devices can constantly give out data of the amount of smoke, of the temperature in that particular flow, and that where the fire is, to the control system, where the control system then can process that data and know whether if the fire is still spreading or the fire is dying down, right? By that, while collecting data from the smoke detectors, the control system can actually then give that information, use that information to increase or decrease the use of the fire suppression system inside the building to control the fire. So that part is the networking of IoT devices inside the building. That is the intranet part of it. Now, when those devices are connected to the internet, that data collected from the smoke detectors will be sent through into the cloud. And from the cloud, we can use different processing tools and messaging tools, pushing out notifications to different parties. What would be these parties? Critical alerts can be sent to the people who are working in the building, saying that there's a fire on this particular floor, please evacuate the building. Right, do not engage with this particular flow, try to avoid it. There can be there can be extreme heat or smoke, so like that people can be informed and told what to avoid, what locations to be avoid when evacuating. The owners of the building can be quickly informed, and they can take quick action to protect people who are inside the building and to protect the building itself. Another automated notification could be sent to the fire brigade with all the data. Can say, okay, this fire is occurring in this flow, it is spreading this much, and so on and so on. When that live data is given to for the fire department, right? If the fire department is connected to a cloud system, to a IoT system, to an automated system, looking at that particular data, they know how much resources that they have to dispatch to control that fire. So they will be on the safety side as well. If there are some poisonous gases emitting from the fire is detected by the smoke detectors, that information can be also relayed into the for the fire department to take necessary measures. It could be and if like to get protective gear which is needed separately for handling such poisonous gases, because in a fire in a, let's say, a manufacturing location, this could be a poisonous gases could be a common thing, because in manufacturing plants there are different types of chemicals being used. Same information can be relayed into the workers, so the people who are in that building and the building owners and the management of the building to take quick action as well. Another device that can come into play in Internet of Things is health monitoring devices. If there are health monitoring devices used by the people who are working on that, like a smartwatch, that particular data can be used to check the health of the people who are near the fire and who are in the building, right? By collecting that particular data, the system or the IoT system would know that if there are humans being impacted, humans being directly impacted from the fire. If that is the case, those information can be given to the firefighters, to the management, and also to the hospitals to dispatch ambulances when needed. And additionally, if people are trapped from the fire, similarly, smartwatches or smartphones can be used to give their location. That information can be also collected. And if they are trapped and need of help or health assistance, right? Smartphones and smartwatches, things like that can work as a part of IoT to find that information, to relay that information through the internet to the necessary parties. Now you can see different multiple components working together, networked with each other, right? The fire department is networked to directly networked to the smoke detectors in a building, so that the fire department can take information from the smoke detectors and take action. No need to wait till somebody gives a call or somebody confirms if there's a fire or not. They will have all the information. The people who owns the building and the people who are working on the building will have that information instantly. So in a time sensitive scenario like a fire, having an IoT system automatically and instantly giving out information, it will save lives, it will save property, it will be efficient, and such application will be helpful for human beings to save their lives, to protect their for companies to protect their property, and to have an efficient way of handling a fire, right? If the fire doesn't spread, the control system doesn't need to use all the sprinkler systems to drench everything, every floor with water and destroy property as well. So there are like these, the first action or the first thing that is needed is to protect human beings, but alongside protecting human beings, these other secondary options can be carried out efficiently. Thus, the destruction or of property would be less, and the fire would be quickly extinguished. So when coming into a fire, right, as soon as it starts, if we can stop the fire, that would be the easiest. So getting fast reactions from all parties is necessary. So we can use IoT to take fast reactions. Think of a system at late night. If that building doesn't have lot of people, or if there are no people in that factory floor or in that office building working at that particular time, and because of a electricity short or something like that, a fire started. In that particular point, only a IoT device or a IoT system, or only a IoT network can act the most efficient and fastest to detect the fire, to inform the necessary parties about the fire, and to extinguish the fire as quickly as possible. So this is a good example of IoT, right? I have made some notes here in a IoT fire, using IoT to control fire or extinguish fire, right? The data of the fire can be taken, right? These the smoke detectors can check whether how far and wide the fire is spread. Will it spread from floor to floor? So as each smoke detector gets activated, that information will be going into the processing units, and those processing units will have a picture on which floors and which areas are affected from the fire, and those information can be relayed to different places. So these are just this is a very good example of different IoT devices working in different in different scenarios. So yes, these notes we covered everything, information of the people nearby. So even the people who are nearby that particular building could be informed as well through this through IoT. That whole system could be automated, right? We can check the health of the people in the building and inform other people as well. So multiple things, multiple sensors, multiple devices are working together now to to restore, not to extinguish a fire that is being which may have been in going out of control if quick action is not taken. Right? So that is the main thing that is needed, the point that is needed to be taken. How a IoT system can be more effective in suppressing a fire rather than going through manual needs. So this is a very good example and application of IoT. Example of using IoT for a single situation. Let's look at a IoT application where the same IoT devices are used for multiple situations or multiple activities, right? So this over here, we talked about gathering data from the environment. We talked about gathering wind speeds to temperatures to the humidity and everything else from the environment. I have also used another example here, which is a device to see the intensity of the light, right? To see how much light we receives to the ground level and how much visibility, thereby can calculate how much visibility we have. One of the best example that we can see is that in cricket matches we have seen umpires using this tool to figure out whether the conditions are ideal for playing cricket or not, depending on the amount of light that is. Especially in test matches, we can see umpires end of the session, closing of the day, near that part, they are checking this machine over and over again to see if the visibility is correct. So all these IoT devices are there to monitor the environment. It could be sunlight, it could be the temperature, it could be the humidity, it could be the wind speed, it could be anything which affects the weather itself. Let's see how these IoT devices can be applied in different scenarios when these devices are connected to the internet, right? Data from these IoT devices, which is monitoring the weather or which is monitoring the environment, can be fed into the cloud or the internet, where cloud computing can take place. And after processing that data, that particular set of data can be used to take decisions or to activate other IoT things. Let's look at a single scenario. IoT lights, right? The information that is taken from the light intensity meter, like to see if the light intensity from the sun on the ground level is good or bad. That information can be fed into smart lights which are in houses, buildings, office buildings or large scale buildings. It could be given to factory floors where thousands of people are working, and lights can be switched on if the light is not enough. And if the light intensity is more than enough, no need to waste energy. These IoT lights can switch off by themselves. That particular set of data can be used to activate and deactivate street lights in a city. The same data can be used to light up or switch off the lights in an entire city block or even the whole city. This would be very efficient. People who need access to lights during dark hours can get the light at the time that they need when the visibility goes down, as well as lights won't be switched on maybe like after the morning time, right? We have seen this multiple times. Street lights especially is being switched on even in daytime because nobody is manually attending to switch off the lights, especially street lights. But when it is connected to a IoT network, when it's a IoT device in Internet of Things, street lights can be switched on and switched off automatically. So energy will be saved and an efficient and productive outcome will be there. Only when the time is right, the lights will come off and no extra energy will be taken, because when there's enough daylight, the lights will switch off. Drivers who are driving long distances or in the road will have safety because there will be lights when needed. Energy will be saved to energy producing companies or the government who are paying the bills for street lights by switching them off at the correct time. So this is using that particular data, this is a single application that can be a small scale solution or a large scale solution. A small scale solution would be a single house or apartment. Then it can then the solution can even get applied to a bigger situation, such as office buildings or factory floors, or any we can say shopping malls and so on and so on. Then making it a much more larger scale situation, street lights can be also activated or deactivated accordingly from a single point of data which is coming from these devices. This makes efficient because this data is being shared with multiple levels by a single device. We don't need, if we are going to we don't need each sensor to each light. We can use one sensor to detect for a particular area, and multiple, maybe thousands and thousands of lights will switch on and switch off according to the data given by one or two sensors. It's a very efficient and productive way. So if you are making a smart home solution, you don't need to have a whole weather monitoring system to switch on your lights. Or we talked about earlier, you don't need a whole weather monitoring devices fixed in your home just to control your air conditioning or the heater or anything. That particular set of data can be obtained from the internet, where there are devices which are already established and giving out that particular set of data. So use of these devices not as a single intranet network, but connecting these IoT devices to the internet will allow a large quantity of people who wants to use IoT to share the data between each other and reduce the cost of having an IoT system established. So this is one of the examples that comes from there. Now you can see from if you are designing a smart home, if you are designing a smart home with IoT devices, you can see that there is a cost cutting solution as well. No need to have all these sensors fixed to a smart home, because that particular set of data can be taken from the internet. So this is what Internet of Things is all about: working together, sharing data to take a productive outcome, right? But the other point that I want to make from this is, the same set of data can be used in multiple scenarios. Data collected from the IoT weather monitoring tools, right, can be used to switch on, switch off lights. We talked about very first application can be used to control the heating or the air conditioning in buildings, air purifiers, right? And that particular set of data can also be used by different industries. For example, let's say the fishing industry. If you are going in a boat into the sea, it is something which is very vital to know whether how the conditions of the sea is going to be. Is the weather going to be rough? Is it going to be windy, right? Is it going to be calm waters? That particular set of information can be obtained from the internet. And how that information is obtained? It is obtained from devices which is connected to the internet. In effect, that data can be taken from IoT devices. One of the industries which used IoT devices before IoT was a thing is the aviation industry itself. Aviation industry in airports, monitoring wind speeds, wind patterns, temperature, humidity and everything, because this will affect the performance of the flight. This will affect the safety of the flight. The flight engineers, to the pilot, to everybody who's working there should know the real-time data of the weather at that particular location, at the airport, or the plane itself has its own sensors to monitor these things. So that means devices that are connected to a network. It could be a network which is inside the airport itself. It could be it could be data that is coming from the internet, from outside resources, right? That means from the Internet of Things, to make correct decisions to whether to delay the flight till a safe time, or to take flight if the weather is good. So that means, so Internet of Things can be that particular data that we get from devices can be used in different scenarios, right? We talked about how these data can be used in one scenario, right? And we looked at an example where multiple IoT devices working together to handle one particular scenario, right? We talked about a device giving out information to adjust temperature. We talked about multiple IoT devices working to handle a critical important scenario or a task. Now we are talking about IoT devices applied in multiple scenarios, right? The other example would be people who are going in hiking or going into remote locations, like top of mountains or something, maybe just for fun. Maybe there will be either high tension wires going in and over mountains, and they need to repair them. So there are situations like that. You will see that there will be antennas fixed on top of mountains, and those are remote locations, but people have to go there. So in such scenarios, the wind speed and the wind speed and the weather forecast plus the light conditions on the ground are very important. Those data is important for them to carry out and to take assessments of the situation that they are in, whether they are in a calm environment to go on that trip or not. So on and so on. There will be thousands of applications, right? Farmers can use this data. Different industries that rely on the temperature or the lighting can use this. For example, solar power plants can use data from these devices to see how much energy that they can produce at a particular given time. Or they can take the wind information about the wind speeds and see not a solar power plant, but in this case a wind farm can see if they can take good results looking at the wind speed. So electricity production can use this data. So here we can see that the same sensors are used for different applications, right, in an effective way. When these devices are connected to the internet, multiple number of industries and multiple number of situations, multiple number of people can take that information and use it to their benefit, rather than having their own device in an isolated system. They can share that resource through the internet, making it efficient and efficient, productive, cost-effective solution. So by now, when you are thinking about IoT devices, you should be able to see two scenarios. One scenario is that to tackle a specific situation, multiple IoTs working together, and IoT device or IoT application of a single IoT device or system or embedded IoT system. There will be multiple users to it, and that particular point also should be considered when coming into IoT, right? So now let's look at a situation where a mixture of the above examples take place. We have a set of IoT devices and we have a set of industries or places where IoT can be applied. Now let's see in how we can mix and match the applications of these IoT devices to these industries. The examples of IoT devices first. There are smoke detectors or smart smoke detectors. There are health detectors. In this example, the picture shows us a smartwatch which is able to monitor the vitals, but do not only think it in the shape of a smartwatch. It could be in any shape or form depending on the vitals that is being censored. This is as an example we are showing. So the third options are motion sensors and contact sensors. So now we can see how these three sensors can be used in three different environments, maybe for the same thing or maybe for different scenarios, but how these IoT devices get applied in different environments. Let's look at the three environments first. So environment number one is a heavy industrial complex or a heavy industrial factory. We can say that this factory is there to create raw material or purify metals, something like that. That means lot of heat is needed, lot of energy is needed. There are machinery to heat the metal into a liquid form. So that means it's highly industrialized as well as highly dangerous working situation where safety would be number one. It could be a cement factory. Same scenario. There is a lot of heat needed to make cement. A lot of raw materials needed to be processed. A lot of heavy machinery would be working in parallel to each other. So safety is a must. Or A coal power plant, same thing, right? There will be a heating element to boil the water, create the steam and produce electricity, which is again heat is there, heavy machinery is there, the spinning turbines, and so on and so on. So then again safety is number one. Here this picture represents a hospital environment where patients needed to be monitored 24/7. It could be a ICU, it could be a normal ward, or it could be a ward dedicated to special sicknesses, right? Think of COVID for a moment. We have to build isolated wards separately for that, and the requirements become different. So that is another scenario. Then another industrial application is mining. Inside, you can see this one is inside a mine where people are going to work, and looking at the picture itself, you can see that there are safety concerns. Mining is mainly done to extract raw material, but also mining is done these days to create underground pathways, railroads, and so on, underground connectivities. So this is also an industry which have heavy machinery, and safety is a concern. So let's see how companies or industries can use IoT devices, or can apply IoT to make their working environments safer, productive, and efficient. If we get the smoke detectors, right, when we talk about smoke detectors, these are smart smoke detectors which will be live feeding what is happening in their environment to a control center. It would be able to monitor the amount of heat, it would be able to monitor the amount of smoke, and it would be able to monitor complex smoke detectors would be able to monitor the kinds of particles that are available in the smoke itself. So the first application here is going to be very simple, right? Heavy industrial environment where a lot of heat energy is needed to give out a product, either electricity or raw materials like metals and so on. Lot of heat is there, lot of smoke is there. Especially when processing coal to produce electricity, or heating up raw materials to create metals, lot of toxic particles are released as smoke. So it is vitally important to have IoT devices to measure that smoke and to see if the working environment is safe for humans at all times. This can help to save lives. It will help the safety to protect the workers inside that particular harsh environment. It will keep an eye on if the machinery or the heavy industrial components go wrong, and if there is a fire element, such as when making cement, you have to heat up the materials to a certain degree, right? Or extracting raw metals, you have to melt down the elements to get the raw elements out. Then of course when producing electricity using coal or gas, then again a heating element is there. That means it is vitally important to measure the heat inside that factory to see if it is going out of control or if it's in control at all times. So again, smoke detectors with temperature sensors would help to get that information. And when the smoke detectors are connected to the internet or to a network, it will become an IoT device, they can share this data live with relevant stakeholders. Maybe the flow manager, maybe the safety officer, the control room, or even the people who are working in the factory floor itself. Now let's look at how these smoke detectors can be applied in an environment where hospitals are concerned. So as we talked about, we talked about there are isolated wards where patients of different who needs maybe purified air to breathe, who has respiratory problems, the ICU, patients that have undergone surgery, and even wards which have let's say even like wards which were created for corona. The amount of oxygen in that particular wards, the amount of purified air, to measure that, it is very important. So these smoke alarms can be used. We have to check the properties of the smoke alarms when fixing them to see what they can measure. But the main reason for fixing a smoke alarm would be to see if there's a fire or something wrong goes on, especially when a fire takes place. Additionally to that particular safety requirement, we can check if there are unwanted particles, could be dust, could be smoke, or something that will deteriorate the health of the people in that ward. Thus, we can use smart smoke detectors to check whether the environment inside the ward, the air inside the ward, is in good condition or not, and that information can be fed in real time to people who need that information to take quick action. It could be the nurses, or it could be the doctors, or it could be the working staff inside the hospital. Similarly, we can use smoke detectors inside mines. So let's look at scenarios where we can use smoke detectors inside mines. When we talk about mining, the very first thing that comes into mind is creating blasts to loosen the rocky environment. There will be explosions, there will be controlled blasts to create to loosen up very hard soil. So when such things happen, when these blasts happen, it is necessary to see that the explosions does not create any fires, or the smoke from those explosions does not reach to places where people are staying. In that point, for that point, we can use smart smoke detectors. Similarly, when going inside mines, when discovering new areas inside the mine itself, this is a caved environment. That means oxygen or purified air from outside should be pumped in for human survival. So there should be real-time monitoring of the air quality and the particles in the air. and there will be while digging and continuing the dig, the machines will hit air pockets and release, it could be dangerous fumes like methane, which will, if overdose, which will kill people. To stop that, it is necessary to monitor the purity or the compatibility of the air inside the mine at all times. So smoke detectors or air particle detectors must be used inside mines at all times to guarantee safety when mining take place. So now you can see that smart smoke detectors or any sensors that measure the heat of the environment or heat in the air, and any sensors that detect what is actually in, what are the air particles themselves, whether they are dangerous or not, can be applied for different industries to accomplish different goals. So same IoT device is used in different scenarios to accomplish different goals. If you look at health monitoring, right, the obvious industry would be the medical industry. The medical industry can use health monitoring tools. It could be a smartwatch, it could be any other device which would be strapped into the patient. It could be even a smart hospital bed itself monitoring the vitals of the human being who's there, which doctors, nurses can use even in real time to see if the patient is stable or not, right? And assign needed treatment for that patient. Think, for example, when a surgery takes place, where the patient would come into a ward or the ICU, and there are different sensors that will be attached to the patient to check the heart rate, to check the pressure, to check the breathing, so on and so on. So if those devices are connected to a network, rather than doctors or nurses coming in near the patient and just checking the readings at that particular moment, these readings can be relayed into a cloud computing system in real time, and check if the vitals are good at all times. Or nurses who are maybe a little bit far away from the patient, doctors who are far away from the patient, who's not in the eye line of that particular patient, can monitor the vitals in real time to see if the patient is becoming stable or unstable after a major surgery. So these are real time users or big users of IoT applications, right? If the patient so one of the scenarios that you can see is even if you take, not all the patients can be given heart monitors and everything at all given times, right? So it's hard to give very expensive machines to check the heart rate or the blood pressure at all times in a patient. So a IoT solution could be giving smartwatches. Smartwatches are less expensive than medical equipment themselves, but are able to monitor simple vitals such as blood pressure and heart rate. And when those watches are connected to the internet, and and this information is directly given to doctors on duty or nurses on duty at that particular given time. They will have a real time observation of patients who are getting stable, who are getting healthy, or who needs treatment. So when coming into the medical sector, IoT devices can do a lot to increase the productivity of the hospital itself. So health monitoring devices, IoT devices, health monitoring IoT devices, the obvious example would be a hospital. But what about these two? Heavy industries or jobs like mining? How can we use these things? So inside a factory where there's a lot of heat, where there's a lot of either where breathing difficulties can occur because of the smokes that are being emitted by the products when making the products. People who are working there can have these have health monitoring devices which are connected to a network, giving out live information about that particular person's health at all times. There are very small devices right now that can actually measure the oxygen levels in your body. The even a smartwatch will have ability, or any device a size of a smartwatch will have the ability to check the temperature of the body. So when you are working near a furnace, right, when you are working near a place where heat is needed to function, keeping track of your personal body heat is important. If the heat itself becomes unbearable, there will be exhaustion and there will be health risks. So monitoring that in a live environment would help help people who are working in very highly industrialized situations. Factory managers, safety staff can quickly attend to people who needs attention, because they will receive alerts instantly from these health monitors. From heavy industries, think about the same inside mines. When there are controlled blasts occurring inside a mine, it is necessary to check if everybody is healthy and good when those blasts happen. Those information can be read in real time. If there is maybe when digging down, if they hit a methane pocket or something like that where poisonous gases are released, it is important to check the vitals of the humans who are working inside the mine at all times till they come into safety. In that scenarios itself, and inside mines, another example is inside mines, the heat is also very high. When you go dug in deeper and deeper, the heat is a lot. So smoke detectors plus can measure the heat of that particular area of the mine, and health detectors can see if the human being who is at that area getting exhausted or not. If the human being at that area is getting exhausted, help can be provided quickly, thus saving that person's life. So now you can see now you can see that health monitoring devices, from the obvious to the not so obvious, can be used to monitor and provide safety and productivity to human beings, right? Because in real time there will be monitoring going on. In the past, these are not a luxury that human beings had. A lot of people died because of safety issues inside mines or large scale factories, especially if there's a heat element to it. So that is one of the you can see that a health monitoring tool or a health monitoring device, IoT device, can be used in different scenarios to give a productive outcome. Let's look at the final two devices that are there. One is a motion sensor device, IoT device, and the other one is a contact sensor IoT device. So mostly these are there to see, rather than taking a visual aspect of it, we are there to see if any movement inside a room is taking place, right? So let's look at the same thing can be applied to all three scenarios. Let's look at how these IoT devices are applied. Let's start from the first one. A factory, right? It could be a industrial small scale factory, like large scale industrial factory, a small factory. It could be, again, what we talked about here was factories that are producing raw materials, which there's a lot of heat, moving parts, mechanical industrial level mechanical machines that are working, mechanical components that are working. Or we can look at similar factories could be cement factories, steel manufacturing factories, even coal power plants that comes into mind. So in such scenarios, when these machines are activated with large amount of heat produced, and when there are safety risks, humans cannot always be near enough to sometimes do the checks of the machinery. If the let's say in a steel manufacturing plant, to see if the large scale cranes are lifting up the heated steel, and if that heated steel or the molten version of the raw material is being moved correctly, humans cannot just go and check those scenarios. So sensors should be used. In such scenarios, motion sensors can be used. For example, let's see, take another example would be the furnaces that are used to make steel. To check whether the furnaces are shut properly or not, we can use contact sensors rather than using the human touch. We can use contact sensors and we can take real-time data out of it. Let's say electricity production, starting from coal, we heat up water, we create immense amount of steam, pressurize it and send it. It is better to use contact sensors to see these pipes, joints of pipes or valves and everything are in place, which are either open or closed correctly, rather than humans going to these dangerous situations and checking them individually. The contact sensors can keep an eye on whether the seals are there correctly, open or shut. So in uh, in factories, if the factory production line is moving correctly, if to see if the doors are closed, to see if the heat is not escaping or if there's no danger, these contact sensors and motion sensors can be used. If you take a hospital, again we talked about this before as well. If you take a hospital, the biggest thing right just happened, if you is the COVID situation. Right, in the COVID situation, we created special wards where access is prohibited to everybody, and it's always kept sealed because so the virus couldn't escape. Before the COVID period itself, there were containment units, separate containment units or separate containment wards in hospitals. The seals of the doors and the windows of these containment units can be kept in check using contact sensors. We can check if the patients are healthy and moving or moving erratically due to pain or something like that through motion sensors. Sometimes elder patients are sometimes requested to take small walks in recovery period, and motion sensors can be used to check whether the patients are moving correctly or if they are in distress, if they are not moving or if they fell down. The motions are different from having a small walk. Either the motions will stop, or when falling down the motions will be very fast, abnormal amount, so that alert can be generated to the necessary doctor, staff and the nurses to attend to that patient. Similarly, the doctors and nurses can check patients in wards. Are they in their beds, or are they having seizures or some kind of erratic behavior is there or not? So there are a lot of situations that motion sensors can be used inside hospitals. And again, contact sensors can be used in hospitals, especially to see if the ICU doors and windows are closed. That would be another example, because there should be a correct temperature inside the ICU. There should be filtration of air inside the ICU, and if doors and windows are open, these things could be compromised. So the applications are there. The industries are completely different, but the applications are there. If you go into a mine, same situation is there as well. When you dig deeper and deeper and deeper, you can seal locations for safety. If a poisonous gas is released, a particular area can be sealed so that miners in other areas of the cave itself would be protected. To check those seals, contact sensors can be used. Miners sometimes use small railway carts to push dirt out, to see if those rail cars are moving correctly, and to see if the connections between those rail cars are done correctly. Motion sensors and contact sensors can be used. Extra dirt can be pushed through conveyor belts towards outside. Motion sensors can keep an eye on these conveyor belts and see if dirt is being moved. Another interesting thing is motion sensors can keep an eye on all the walls around the cave to see if they are solid or are they moving. Are rocks falling from above while mining is taking place, and to see if it is a safe environment or not, motion sensors can be used. And these motion sensors can detect unnecessary or unusual behavior of rocks when they start to fall down or something. So warnings can be given in real time. So as you can see, again, sensors can be used in different scenarios to accomplish different things, right? So we first look at IoT application in a single line form, right? From the IoT device, which takes in data, collects data, inputs data, network through the internet towards the IoT devices that outputs data. Then we looked at a example where a single situation is addressed by multiple IoT devices inputting and outputting data. A single situation. Then we looked at an example where multiple situations, multiple scenarios, getting information from single IoT devices. Single IoT device or set of IoT devices providing information for different scenarios, providing data, providing outcomes for different scenarios. Then for the last example, we checked a mix and match of situations where a set of IoT devices can be used in different working environments. We mixed and matched, and we saw that how these devices can be, we looked at examples or scenarios that these devices can be used in different working environments, such as manufacturing plants or power plants or hospitals, or even harsher places like mining. So right now we went through the chapters. We took an introduction, we got to know what are IoT devices, and we saw how these IoT devices network together gives a IoT application. We look at all these we looked at all these scenarios which were taking place in the world today. Let's take an introduction to the basic IoT architecture, right? So we are going to look at the basics, the very basics, and we are just going to take an introduction to see what is there when creating a IoT architecture. When a basic IoT architecture is created, when we see a problem and we want to give a IoT solution, we make a IoT architecture, and this is the wireframe of that. What will be the components there? So let's go through the statements first. IoT, or the Internet of Things, refer to the interconnected network of physical objects. We talked about this in the definition of IoT, right? So these physical objects connected in a network. These physical objects could be devices, sensors, and software applications that are running these devices and sensors connected in a network, right? That communicate and exchange data with each other over the internet right? We talked about how that happens, right? We talked about how physical objects or devices connect with each other, right, over the internet, right? So that is the definition. Let's look at it. Like, let me go through the sentence from beginning to the end. IoT, or Internet of Things, refer to the interconnected network of physical objects, devices, sensors, and software applications that communicate and exchange data with each other over the internet, right? That is the definition. That is IoT, right? Wordings could go a little bit different in different definitions. If you check in the internet, it would be different as well, but there are things that you need to highlight when defining IoT, right? It's a network of physical objects or devices, so there should be the mentioning of the hardware portion of it, and the networking of that hardware should be mentioned. That is a must, right? So in the network itself, data and everything is communicated, processed. There will be, of course, there will be software to facilitate the networking and processing and storage and so on and so on. So that it, again, the highlighting part of is network of physical objects. So there's a hardware component, there's a physical component, that means the hardware component, and the networking of that hardware component is Internet of Things. So let's look at what are the main components which makes IoT, or in a IoT architecture, what will be there, or what is needed to create a IoT system. So this is what we are going to look at. Number one, we call it the perception layer, which are the devices or sensors. This is the perception layer, which is the device or sensors. That means the hardware component of it. It is the hardware component of it. These are the physical objects or devices that are connected to the internet and collects data for or perform specific tasks, right? So the hardware components which takes in the input or the output of it. That is the perception layer. That is the outermost layer. They can be anything from a smart thermostat, we gave examples in above, a wearable fitness tracker, again we talked about them, or a smart home security system. So you can see the examples. We went through these examples before when start giving examples about IoT devices, right? We talked about, again, fitness tracker, security system, right? We gave those in the first lecture itself when talking about devices. So the perception layer is the physical devices or the hardware components of it. They take in data. Also, these physical components give out data or information, processed data, or give output in the form, in a physical form, maybe an actuator movement, a motor movement, or opening a valve or closing a valve, right? We will look at these examples of sensors and actuators, then processing units, controllers, in the future lessons, right? Right now, one of the layers that we have to understand when building the architecture of an IoT system is the hardware devices or the hardware components. When there's a problem and when we are giving an IoT solution, the IoT solution should contain, without a doubt, a hardware element to it. IoT by definition has a hardware element to it, right? And we looked at examples. We looked at our examples here. There are sensors to sense our motions, contact sensors. Then we talked about cameras, sensor to sensor the temperature, and so on and so on. These input data into the IoT system, right? In the same IoT system, right? We can, from these inputting devices or physical objects, there are output physical objects such as plugs to control the electricity flow. Control systems are there to take to give information to the human in verbal form or in a display wise, take in commands from the control center, right? If you take a robot arm, there will be actuators and motors moving up and down depending on a contact sensor or a proximity sensor. A Roomba vacuum will go around checking around for using a proximity sensor. There will be image or a capacitance sensor to check the fingerprint, and when it is authenticated, there will be an actuator to push the lock and unlock it, right? So these are the components. So there are physical components that our eyes can see, right? So when building a IoT architecture, the first component is the physical layer or the perception layer, where devices and sensors are there, right? So we are talking, the first layer contains physical objects. Then we talk about the network layer. This refers to the networking infrastructure that enables the devices to communicate with each other and with the cloud. Cloud computing is a thing that we cannot run away from these days for processing storage data, building virtual networks to virtual processing environments, sharing hardware and so on. I think you have learned about cloud computing. So IoT devices by default these days, when connecting to the internet, they connect to the cloud. So these so examples of networking would be Wi-Fi, Bluetooth, cellular or satellite connectivity. So normally when a thing is connecting to the internet and building the internet of things, network is the next fundamental layer that is needed, right? When building an IoT architecture, by definition it should be connected to the network, to the internet. Then that should be done through a network. Here few examples are given in a wireless networking system, but it could be a physical network, it could be a wireless network, depending on the requirement. Of course, you know, when we talk about our above examples, right, most of these examples, there will be an intranet inside these units, right, to monitor these things. Sometimes the internet is not getting involved. Everything is processed inside either the factory or the mining area or inside the hospital. So there will be networking between each other, right? We talked about networking. The best example is here, when a single scenario, when the fire occurs, how data is communicated to control systems. The control systems then communicate back into, here we can see the perception layer or the devices connecting through the network layer to other things in the perception layer, control devices. Then those control devices connecting through the networks into outputting in physical objects or hardware components, which is again the perception layer. You can see the perception layer connecting into the cloud through the network. So again, Wi-Fi connectivity or in cabling or anything, even satellite for checking GPS locations and so on can be used. We will in future discussions we will look into the networking of IoT devices inside an embedded IoT system, as well as an intranet or a small IoT closed system, and then connecting to the internet itself. Because in that we will talk about some important facts, such as why there are different kinds of methods of having networks, different protocols, and different networking methods are there. Why we use them? What are the reason these methods are used in IoT? Right? These two, the device or the sensors making the perception layer and the network layer together makes embedded IoT device, right? For example, inside this autonomous driving vehicle is a network of IoT devices. This vehicle itself is an embedded IoT device, but these IoT devices are networked inside. These sensors, these devices, these hardware components, sensors, actuators, motors, processing units, these hardware components are networked inside to create this IoT embedded device. Another good example would be the fridge. There is an internet component to it. There are displays, there are lighting, there are motors working to cool the system down, there are cameras to keep to check inside, there are lighting when the doors are open, there are automatic door opening closing. So everything, so there are hardware components networked between each other inside to make an embedded IoT device, and that embedded IoT device or this smart fridge is connected to the internet. Then this smart fridge becomes a thing in Internet of Things, right? Then of course the cloud platform or the service layer, right? When talking about the internet, we cannot escape from a cloud platform these days, is for obvious reasons, right? Anybody who has learned about or researched into cloud technology knows the benefits of having cloud technology when coming into maintaining networks, virtual networks, sharing resources, storage, safety of data, the immense processing power that it brings in, and so on and so on. So the cloud we call it the service layer. The third one of the main four layers, this one is called the service layer. The cloud platform is where the data collected from the devices, that means from the perception layer. So the data that is given out by the perception layer is stored, processed, and analyzed, right? So this service layer could be the cloud itself or an internal processing system as well. That is something that you should need to remember, right? So for example, if you go to if you go to our examples again, let's go to the smart fridge, or the best example, autonomous driving vehicle. If you study how these cars or vehicles are built to drive by themselves, the vehicles themselves process this data to give the output. They drive by themselves. They do not release that whole like the entire sets of large number of data into the internet, let it process and come down, because there will be a delay. So all those large amount of data which is coming through the sensors are processed inside the vehicle itself for a quick response. So in that particular scenario, in this embedded IoT device, which is the autonomous car itself, a service layer is there to store, to process, and to analyze the data which they get from the sensors around the car. It could be the LiDAR, it could be the cameras, it could be proximity sensors or accelerometers or things like that, right? But if you take an example like, let's say, a factory, the head office of that company maybe in another place, and the information of the products, which what is going on, the safety and everything, that could be updated into a cloud, and weekly reports can be created, monthly reports can be created, the amount of energy that is being used, or the amount of product that is being made, or so on and so on, right? And for that they can use the cloud itself. So all the IoT devices inside this factory could be connected to the cloud, and the data collected from these IoT devices can be given to needed parties through the cloud in real time, as well as stored inside, processed to create reports, analyze, and maybe they can analyze 3 months of progress, whether it's going good or not, so to make those data as well, right? So one of the other things we talked about, when a fire occurs, the controls, the perception layer connects to the network and use the cloud as a service layer to process data, right, and send the data to the relevant parties. It could be building owners, it could be the fire brigade, right, sending alerts to people who are in the building itself. There's a perception layer in the cloud itself, but it is necessary to understand, when we were giving this example, we talked about how the smoke alarms or the smart smoke detectors detect the smoke in the perception layer, where the device through networks give to another perception component, which is the processing area, where these controllers act as the service level. They process that data and identify where the fire is, rather than giving the data to the cloud and taking back again, right? They make a quick calculation, quick decision, and switch on, go back to the perception layer or the hardware layer, and switch on the sprinklers, right? So in this you can see the control panels, or the physical control panel itself is a part of the perception layer, because it gives the output as a display, but that output is given through processing, and that processing happens inside these controls, right? So if you take if somebody who's taking care of that building has a computer with them which processes this data, or a small data center inside the building itself, the display would be the perception layer, but there will be processes taking place inside the small data center, or where the CPU is. So that would be a service layer. So in this example itself, we identified two service layers or two positions of the service layer, right? When coming into IoT, when everything is connected to the internet, cloud is the default. Cloud is the default topic for service layer, processing data and keeping data, right? So in this lesson we would be talking about embedded systems, embedded IoT systems mainly. So embedded IoT systems would consist of devices or a physical layer which includes sensors, actuators and processing. That means the perception layer would have inputs and outputs, right? Things that physically humans can see, and sensors to take in data. And in that embedded system we will use the service layer, small controllers with processing power, rather than going to the cloud itself. But in a large scale IoT application, to a smart home or to an office building, hospital, power plant, nuclear power plant, to cruise ship, logistic ship, to an airplane, to an airport, to everything, a cloud platform will be the best option as a service layer. And you can see the examples which are given, right? Amazon Web Services, Azure and Google, they have separate components in their cloud platforms to support IoT devices, to take in the data, to process the data and give output, right? To build virtual networks and so on and so on, right? So the service layer, right? Today in IoT, the service layer is cloud platforms. But when you are making, when we are talking about service layer, the processing, the storage and those things not only happens in the cloud itself. There could be personal data centers, or like data centers that belongs to, let's take a military base. In a military base, it is safer to keep the data and process the data which are taken from IoT devices inside the military base, to keep that particular data inside the military base itself, rather than giving it to the internet. So there will be no compromising of data. So in that case, there will be a service layer, but that service layer belongs to not to the internet but intranet. So when coming into IoT and giving IoT solutions, one of the things that is needed to be we must understand the scenario of it, right? It's not always the cloud, it's not always the internet itself, right? Sometimes it could be an intranet, right? And it would be other processing devices as well. But in general, right, when coming to network, it won't be always Wi-Fi, it won't be always Bluetooth or cellular or satellite connectivity. There will be others as well. We will talk about these topics in the future. So what we are looking at here is a general understanding of the architecture. There's the perception layer, where there will be sensors or devices, the physical objects, right, we take in data and give out data in the forms of giving out data would be in a form of a motor, actuator or a screen. The network layer, of course, connecting all those devices that are there on the perception layer. The cloud or the service layer to process, store those data. Then in the fourth layer, it would be the application layer. The application layer refers to the software applications or service that are built on top of the cloud platform or the service layer to provide specific functionalities to users. The application layer provides the user facing interface and functionality of the IoT systems. So what we are looking at is, in general term, the service layer would be the back end of the internet. The application layer would be the front end of the internet, right? If you have, for example, a large factory controlling unit, the displays in the control unit would be the application layer showing the data to the human being. The displays itself would be a part of the perception layer because it's a hardware device, right? The data would be coming into the displays through a network. So these are the things that we have to understand. These layers. So these 4 layers are needed to build a IoT system, right? Application layer could be, again, literally an app in your app store. There are products. You have seen when you buy some physical products, there will be apps created to help to work with that product, right? When you use those applications, that would be the app. The data, the physical object you have, or the right, would be the IoT device, which is the perception layer, right? When you take a smart fridge, you will have an app with you to see the status of the fridge. If you have a Roomba, you will have a app to most of those automated vacuum cleaners now has an app to see the status. A smart lock will have an app to give you notifications on if the smart lock is activated or not, who's entering, who's going out, who's going in, to register new person's fingerprint or change the password or so on and so on, reset the lock. There will be an application for that, right? And that now you can see the smart lock is connected through the network. The smart lock is the perception device. It's a hardware component. This hardware component is connected to the network, right? The hardware device is connected using the network to the cloud, so that the data which is taken from the perception layer, which is the fingerprint data, will be sent into the cloud, encrypted, of course, in the network layer. It will be encrypted and sent into the cloud, and the cloud will go through the database and check whether it is authenticated, send the data back in to the device, opens the lock, as well as send a notification to the owner of the house or the building or something through the application layer, right? Or there will be a secondary authentication system. The cloud will inform the person who's in charge through the application layer, saying this person is there. We have detected his fingerprint on the lock. Shall we let him in or not? Then the controller can give the signal to the through the app to the cloud, through the network to the device. Then the lock opens, and the person could go in. This is that's a example of a IoT device in action. And to build a IoT system, the architecture of the IoT must contain a perception layer or a physical layer, which includes devices, sensors, which includes hardware components. Then the network layer, which includes different types of communication, secure communication. The service layer or cloud platform, where the data is stored, processed, and analyzed. Then the application layer, where the users of IoT interact with the IoT device or the IoT system. These are the four things that should be there when creating a solution for using IoT for a problem. You will see the problem or you will see a need. You will create a IoT solution. That IoT solution, when creating that IoT solution, the architecture of it should contain these four layers or these four subjects. And having these four subjects together, you will be able to create a IoT system, and that system's architecture again would have these four layers or these four main components. After this, right, so we took an introduction to the basics of IoT architecture. The basics of IoT architecture is simply includes these four layers, right? Then we can go into the introduction to basic IoT components, right? So we talked about what are the layers which is making IoT. Now we are here to talk about what are the components which makes IoT, right? So when we are talking about components, when we say the word component, that in itself means that there's a hardware portion to it, there's a physical portion to it, there's an object to it. We can see it, we can touch it. It's not like software, right? So we are going to talk about components, we are going to talk about hardware components, right? Which are the basic hardware components which are there when creating a IoT system. So as we talked about before, right, there are devices or sensors in perception layer, right? So that means we are going to talk about components in the perception layer, right? Basically what we are going to take a introduction of the IoT components is we are going to talk about physical objects that makes the perception layer, physical objects that makes the network layer, physical objects that makes the service layer, or even physical objects that makes the application layer. So we are going to talk about those physical objects when we talk about basic IoT components, right? Let's see what is the introduction to basic IoT components. The statement: IoT components are the building blocks of IoT systems. These components can include sensors, actuators, embedded systems, and network devices. So these components, right, contains sensors, actuated, embedded systems, and network devices, right? The main points we are going to highlight here is, if somebody asks what is the basic architecture of IoT, is these four layers make a IoT system. Every IoT system is made out of these four layers. So when you create a solution, the architecture of it would have these four layers. When talking about IoT, there's a physical, we always talk about a physical object, components, we talk about them. So what are these physical objects? What are these components? right? In this, we are going to look at what are these components, what are the main categories of these components. Don't worry, in future, in future lectures, we are going to go through one by one sensors and actuators and everything. We are going to take an introduction, what are they, what do they do, and so on and so on. So first, let's look at what are the main components or the basic components of IoT, right? In another word, what are the physical objects or what are the things in Internet of Things? Number one is sensors. IoT sensors are devices that can detect and measure physical or environmental conditions such as temperature, humidity, light, motion, pressure, and sound. We talked about examples above, which give good examples of some of these sensors. These sensors are used to collect data from the environment and send it to IoT systems for processing and analyzing. Simple. These sensors detect and measure physical or environmental conditions, right? Sensors detect environmental conditions. Also, let's look at the examples we checked again. Let's go to the devices and we can see what are the sensors that would be there. In a camera, it would be image sensor would be there to take in the video of it. In a temperature monitoring, there will be a sensor to check the temperature, right? Motion sensors, right? That means there should be a sensor that could detect movement. It could be a small radar or something like that, Doppler radar or something. It could be something like that to detect movement. Contact sensor is as you can see in the definition, it's not these sensors to check the environment, right? So smoke detectors are there to check the environment, to check the temperature, to check the particles, the smoke particles in there. Contact sensors are to check again. Let's go to the definition, right? To detect and measure physical or environmental conditions. So contact sensors can check physical conditions such as a door closed or opened, or if it is sealed or not, and so on and so on. So we can see now little by the smart lock has a fingerprint sensor. A smart fridge would have a temperature sensor. It would have a contact sensor. It would have it would then again it would have sensors to check the temperature, the coldness, and even if there are rotting food inside, there would be sensors to check whether the air inside the fridge is clear or not. There will be light sensors, so on and so on. A robot arm or a Roomba would have proximity sensors, accelerometers, gyroscopes, those things to understand their surroundings, their space. Even virtual reality gaming would have sensors of accelerometers, gyroscopes to understand the space they stay in. If you take a health monitor, there would be pressure sensors to see your blood pressure. A pressure sensor could also detect the pulses through your veins. Autonomous driving vehicle would have literally every sensor that you could think of, from checking whether it's raining or not, sensors to check the humidity, or the texture of the road, from sensors, cameras, accelerometers, gyroscopes, so on and so on, to check the pressure inside the tires. There will be thousands of sensors. Weather monitoring, again we talked about humidity, temperature, wind speed, so on and so on. So then, looking at the examples we looked at before, now we can understand there are sensors inside these devices which collects this data, right? Which collects this data. It could be temperature, humidity, light, motion, or pressure. We talked everything. We talked all of these factors in when talking about IoT devices. Now we know that there are sensors inside these IoT devices to measure these things. They collect that data, right, and send it to a IoT system for processing and analyzing, right? So we know that sensors are a main component of IoT device. IoT device or a thing in the Internet of Things contains sensors to detect and measure physical and environmental conditions, right? They will collect that data and give it to processing or analyzing. By processing and analyzing, we can take a outcome. As we have covered 2 hours in this lecture session, we will move talking about rest of the components, including actuators, embedded systems, and network devices, to the next lecture, right? So we can take a smooth transition from taking introduction to the basic components of IoT to then getting introduction to sensors, actuators, to the network and embedded system one by one, right? We will then finish this part on the next lecture, and we will go to taking introductions of each of those components one by one, where we will look into sensors, then actuators, networking, controllers, and so on. And we will just look into some projects as well, which we will then step by step try to understand what are the problems and how to give solutions and how to build a small embedded IoT system.